Hai, Assalamualaikum warahmatullahi wabarakatuh. Bismillahirrahmanirrahim. We meet again in our online class. Today we will continue our topic for the final part in chapter 2. Okay. Chapter 2, the final part. DC and AC meter. Okay. So we have done this. So this DC ammeter, DC voltmeter, DC ohmmeter. So today's class we will cover 2.5, 2.6 and 2.7. Okay, this part. Learning outcome. At the end of this subtopic, the students should be able to explain the construction of AC voltmeter, explain the difference between half wave and full wave AC meter, voltmeter. So now we have half wave and full wave. What is this? And third, analyze the AC voltmeter, analyze the AC voltmeter circuit and loading effect of AC voltmeter. So basically today we are discussing about AC, alternating current, because in previous topic we have only discussed about DC. Previously we discussed about DC, but today we will discuss about measuring or converting that the voltmeter movement into AC voltmeter. Okay. There are several types of meter movements that may be used to measure AC current or voltage. Several types of meter movement. So we have learned in this subject only one, which is known as the meter movement, or PM, permanent magnet meter, permanent magnet moving coil, PMMC, or the meter movement, DMM. Yeah, sometimes you see in the book. Okay, so there are, besides this PMMC or DMM is similar, so only one we have discussed. Besides this, there are several other types of meter movements that can be used to measure AC current or voltage. The 5 principal meter movement used in AC instrument are listed in table below. So what are other types of meter movement? So 5 major meter movements are listed below. First is electrodynamometer. Okay. First is electrodynamometer. So it can be used to measure DC and AC. Second is iron vein meter movement. So it can also be used to measure AC and DC. Third is electrostatic meter movement. Yes, can be used to measure both AC and DC. Number 4 is thermocouple meter movement. It can be used to measure both AC and DC. And number 5, which is the meter movement or permanent magnet moving coil. can use both measure DC. Yes, we have discussed in length about this, using the Ascend verb to measure DC. And yes, it can also be used to measure AC, alternating current, but with rectifier. Okay, so today we will discuss about this topic. Okay, so sine wave. So AC, what is AC? Is the most simple AC signal is sine wave. Okay, sine wave. So this is a typical sine wave signal. You have normally the signal is given in terms of magnitude lah, either voltage or current, and it is plotted against either T or phase. Okay, so phase, now it is in phase, so this is phase degree. Okay, 0, 90, 80, 180, blah blah, this is in phase. Okay, so one cycle starts from 0 to 0, or from peak to peak, or from negative peak to negative peak, or from here to here. Yeah, one complete cycle. Okay, in AC, it is little bit different with DC, because in AC we have first we have RMS, root mean square. RMS means root mean square. How we measure RMS? So there are certain value in AC. First is peak. Okay, peak is the top, the highest value from 0 to highest value. It is the peak. Okay, from there is another one, we call it peak to peak, from here to here. V peak to peak equal to 2 V peak. So V peak, twice V peak is V peak to peak. Okay, whereas VRMS equal to V peak over Z2. So V peak, you know, from 0 to the peak. So root mean square is the value where V peak over Z2. So VRMS equal to V peak Z2. So if you ask why the question is like this, there is a long derivation for this. Okay, there is a mathematical equation to derive. But if you want to know further, then you can ask your professor, Mr. Google, and it will give you the answer straight away. Okay. The second term is average value. We call it V average. So this is V average. Equal to, this is the equation, 2 V peak over pi. So this is V average. Okay. So here RMS is V peak multiplied by 0.707. This is the same. 0. This is 1 over 2. 0.707 equal to 1 over 2, right? And use your calculator and take your calculator and calculate. Okay, average value V peak multiplied by 0.637. 0.637 equal to 2 over pi, right? Pi is, you know, by 3.142, right? Okay. So the center must be 0. Here must be 0. Center line may also be 0. Okay. So what happen if the DR server is connected to AC source? Because of the nature of AC, it is, we call it ulang alik. Yeah? So you can see from the figure just now, it has the positive and negative. So meaning that this source in positive cycle, for example, the current will flow this way. Okay, but in another cycle, it will flow this way. Okay, so you can imagine that if that happen, then this needle, due to the current flow in the coil, it will become like this. Okay, one time this way and another time this way. Next time this way and another time this way. So that is the problem. So the needle become wobble. So if AC going through this movement will cause the needle to flutter back and forth uselessly. So you cannot show what is the real value. So that is the problem with AC if we using the DR server meter moment straight away. Okay. Previous lesson we say that we put the battery here, right? Battery is a DC source. Okay, but if you put AC, then problem. Okay, so how do we modify this? How we'll solve this problem? Okay, how to modify the accelerometer moment to be an AC meter to measure AC voltage or AC current? How? So needs for rectification. So we need to rectify the AC signal. What is the meaning? Previous. Okay, so the answer is we are using this. What is this? This is a diode. This is a component, electric component called diode. Okay. So what is this do? The diode will convert AC source to DC source. Okay. So diode will convert AC to DC. So if people ask you what we use to convert AC to DC, you can use diode. What is the process? Rectification or rectifier. Okay. Diode is also a most common rectification device. Diode is rectification device or rectifier, they call it. Okay. Diode is non-linear device. What is the meaning of this? Diode is a non-linear device. What is the meaning? Okay, let me show something. So what is the meaning of this? Diode. Okay, this is diode, right? You can see this is diode. So diode, it has this is called IV curve. I against V, current against voltage. Normal if linear, then you have we call it what? Berkadar terus. Linear relationship. If you increase the voltage, then the current will increase. That is the linear. But here, non-linear, what happens is if the voltage here increase, see the voltage increase, basically there is no current before V on. Okay, before this point there is no current flow, almost zero. Okay, but if you exceed the V on here, around 0.7 volt, then the current suddenly increase. Okay, it's not proportional to the voltage, to the voltage. If proportional, then it should be straight line. Yeah. So likewise, if in reverse bias, if you increase the voltage in reverse bias, reverse means you change the polarity of the battery of the supply. Okay, if you change, if you apply voltage, there is no current, no current. But at certain value, then suddenly the current will increase. That value is called breakdown voltage. Okay, V breakdown. So from this figure, we can conclude that diode is not a linear device, or diode is a non-linear device, they call it. Diode is a non-linear device. So this non-linear comes from IV curve, which I have shown just now. Current voltage curve. Okay. So in this topic, we will discuss about two type of rectifier. One is half wave, and second is full wave rectifier. Okay. So this is the AC sine wave. Okay, this is the sine wave AC signal. When we say it is AC, then you can imagine it is sine wave. Sine wave has, this is positive. We call it positive cycle. This is negative cycle. Okay. So nowadays we are very, previously sebelum ni kita suka positif, right? Semua nak positif. Dalam kes COVID ni kita suka yang negatif. Kalau boleh kita tak nak yang positif COVID. Okay. So that is what happened lah. So positive and negative. Okay, so positive for half wave rectifier. This is half wave. You allow only one way, one side of the signal. So for example, if you have positive, the circle allow only positive cycle, so you have one complete cycle have both positive and negative. So if you use a half wave rectifier, then only half of the signal will be going through. So only half of the signal can be used. So that's why now you don't have the negative cycle here. Okay. On the other hand, for full wave rectifier, you have both positive and negative, but this time it is all in, the output is all in positive. Okay, the negative become positive. So this is positive cycle here, but the next cycle, the negative become positive. Okay, so once you have a full cycle, but the negative become positive. That is called full wave rectifier. Okay, so allow current flow in positive cycle or unidirectional current flow. So this is a rectifier. Rectifier allow current flow in positive cycle or unidirectional current flow. Okay, Unidirectional means one direction. So instead of AC, you have both direction. Just now, remember, half cycle they go this way, and another cycle they go this way. But using rectifier, now it has only one direction. Meter reads in DC or average in AC waveform. So for the Diason Voltmeter moment, we measure in the meter reads in DC or average. DC equivalent, okay, DC equivalent or average value of AC. Okay, imagine example. So in previous part of this chapter, we have discussed that this Diason Voltmeter moment. So Diason Voltmeter moment is this one. This one is what? This is voltmeter. So AC voltmeter. You still remember is voltmeter? Basically, we have meter movement. Okay, so meter movement it has RM and IM ataupun I full scale, right? So I full scale is the current needed to deflect the needle, right? Full scale. So if you want to convert to voltmeter, you need to put one resistor, series resistor, large value of series resistor, so that this become voltmeter. Okay, so let's say this voltmeter has voltage of 10 volt DC, battery 10 volt DC. Okay, so this, the current will flow here, and you have this full scale, the needle or the deflect, the needle will deflect full scale. Okay, so what happen if we convert this voltmeter, DC voltmeter into AC? So to measure AC, you need to put rectifier. Okay, this is where it comes diode or rectifier. So the rest is the same. So you have RS here, RS. This is the Diason Voltmeter moment. Okay, but now the voltage is AC. Voltage is V RMS, 10 volt RMS AC. It's not DC anymore. So this is the contoh perbandingan how to convert DC to AC. Okay, so this is AC. Okay, so in this case, this is half wave, because it only allow this cycle, only positive cycle. Okay, so if negative cycle this way, there is no current flow this way, because at this, when the current reach here, this is act like open circuit. So the current cannot go this way. So it only allow positive cycle, one cycle only. So this is called half wave rectifier. Okay, for half wave rectifier, half wave rectification, Okay, so this is V peak equal to VRMS multiplied by, you still remember the equation, VRMS equal to V peak over Z2, right? So V peak, V or E is equal Z2 multiplied by V peak. So this, sorry, V peak is V RMS. So this is VRMS multiplied by Z2. So the average value or DC value for V half wave, for half wave, because you only have one peak just now, you only have one cycle, not two, because only the positive part going through. So the average value for half wave rectification is Vp over pi. Just now we say it is 2, right? 2 Vp over pi. Va, this is for full wave. But for half wave, you have only 1. So we average Vp over pi. So Vp over pi, if you convert that, it become therefore Vp equal to, convert to VRMS. We got this equation. So you got this equation. This is for half wave. So you can take your calculator and use your calculator to take out this value. Okay. So it is V average for half wave equal to 0.45 V RMS. Okay. Therefore, the pointer will deflect for a full-scale 10-volt DC is applied and only 4.5 volt when a 10 RMS sinusoid signal is applied. Okay. So this sentence said that if you use a 10-volt DC, the same circuit, if you use a 10-volt DC, the pointer will deflect full scale. Okay. The pointer will deflect full scale if you use 10-volt DC. But if you use 10-volt RMS AC using half-wave rectifier, then the pointer will only deflect up to 4.5 volt. Okay. Or 45% of full scale. 45% of scale. If you use 10-volt DC, it deflect full scale, but if you use 10-volt RMS, it will only deflect 45% or 4.5. Or in other words, if you use 10-volt RMS, it means it is equal to only 4.5 volt DC. Okay. So from that, the DC voltmeter sensitivity is the same. Okay, the calculation, the DC meter sensitivity, we have discussed about this. S equal to 1 over I full scale, right? You still remember this equation? Unit is kilo ohm per volt. This is the sensitivity. Sensitivity DC. DC is I full scale. Okay. For AC sensitivity for half wave, because it's only 45%, then S SAC, sorry, SAC equal to 0.45 SDC. Yeah. Means that it is only 45% of DC. So equal to, if SDC is 1, then it is 0.45 kilo ohm per volt. So for half wave, then it is only 45% sensitivity of DC. This means that an AC voltmeter is not as sensitive as DC voltmeter. Okay, AC voltmeter is not as sensitive as DC voltmeter. Okay, AC voltmeter half wave rectifier. So from that circuit, this circuit, this circuit, RS, RM. So from that circuit, you can see the circuit, it has RS, diode, this is meter movement. Okay, so here we have RM, there is RS. So this is the current I, this is the EDC, E. Yeah. Okay, so from this circuit, R total is RS plus RM. RS plus RM in series. By assuming that the resistance for diode is 0. Resistance for diode is 0. So you get R total, RS plus RM. So equal, therefore, this R total equal to V over I. This EDC over current. So R is EDC over I full scale. Or IM. IM also can. Okay, so what is RS? So we are interested in to know what is the value of RS. So from this equation, you can solve for RS. So RS is ADC over IFS minus RM. Sorry ya. Boleh ataupun previously RS is R total. R total minus RM. Then it go this way. Okay, so you understand this? Okay, but in this case, EDC is equal to, for half wave rectifier, EDC is equal to 0.45 ERMS. Okay, so the equation become like this. So this part is 45% just now of this. Okay, therefore RS is S multiplied by, where is this S coming from? S multiplied by, this is 0.45 RMS. Okay, minus Rm. So here S is 1 over DC, I DC, right? Here. This is 0.45 RMS. This part is S. Okay, so S multiplied by this one. Okay, you settle this one first, and the minus. Okay, so you understand this equation, eh? So in general, multiple resistor RS, in general, multiplier resistor RS can solve using this. RS equal to SDC range minus RM for DC, and for half wave rectifier, RS SAC multiplied by range AC minus RM. Okay, so hopefully you can understand this question. So this S and this is range. So what is range? Range, eh? So this voltage. Okay, example. Okay, you can try this example. Compute the value of RS. Okay, what is the value of RS? This RS for 10 volt RMS AC range. Okay, so this is the range RMS on the voltmeter shown in figure 1. Given that E 10 VRMS here, so here is the 10 RMS. You can use this symbol 10 VRMS. Okay, you can also use plus minus here, or normally AC we use this symbol. IFS is 1 milliamp here, IFS or IM. IFS or IM is the same, 1 milliamp. RM is 300 ohm. RM, this is RM, 300 ohm. So RM is the ensemble meter movement. So now you have this diode. So what is this? This is a half wave rectifier circuit. So this is one diode is half wave, half wave. So how you solve this for RS? Just use the equation. Just use this equation. So what you need to find? Just put the value and you get the answer. Okay. What is the equation? Okay. Take your time and solve this problem. Do yourself, huh? Okay. Okay, let's say, let's see the question. So do you think that you need to draw? If you think you need, then you just draw. Okay, this circuit RS. Sorry, we have this and this diode, and then change it. This is RM. This is RM. This is RS. This. Okay. So this is 10 VRMS. This is 1 milliamp, and this is 300. Okay, right. So the equation says that RS equal to S multiplied by range minus Rm. Okay, so S is 1/1 milliamp. Range 0.45 multiplied by 10 VRMS. Okay, because it is half wave. Okay, so you solve this part first, and then multiply and minus 300 ohm. And solving this equation, you get 4.2 kilo ohm. So RS is 4.2 kilo ohm. All right. Okay, so you should be able to solve this calculation. If I give the exercise, I'll be changing this value. You might have different value here, or different value here, or different value here. So in order for you to answer, then you should know the calculation. So this is Rm. This is, you have to use this 0.45 because this is half wave, and then this is the range. Okay, so that's it. Easy, yeah. So this is S. S is related to Im as the sensitivity. Then for half wave, it is 0.45. But if in full wave, after this become 0.9, double from this. For full wave, this part diode will slightly change because you need to modify the diode. There are 4 diode being used, and so that the current will flow. The current can flow this direction, always this direction, to the emitter movement. So we will see that later. Okay, understand this one? Okay. For commercial voltmeter, half wave rectification. This is the next example. The how they put the diode for half for the commercial. So why this is going quickly? 1 second. Okay. Okay. So let's see this circuit. This is called commercial AC voltmeter for half wave rectification. This is still half wave, but for commercial, they use two diode instead of one just now. For commercial, they use two diode, D1 and D2. Why? And it also have extra resistor called RSH. RSH, sometimes, normally this is referred to shunt resistor. SH is shunt. Okay, shunt. S-H-U-N-T, shunt. So for this commercial layout, half wave rectifier, they use a shunt resistor. Why? First is to increase current flow through D1 during the positive cycle, positive half cycle. So D1. So positive half cycle, the current flow this direction through RS, and then here it cannot go. just going through this. Okay, so the current will divide here and here. Okay, diode will operate in linear region. Diode will be operating in linear region using RSH. Improve linearity of AC meter during measurement of low voltage. Okay, but further reduce AC sensitivity. That is the story of shunt. So you have this kind of layout for a commercial AC voltmeter. Okay, for so D2, what is the story? What is the function of D2? Half cycle, positive half cycle, there is no current flow, no current, because this is reverse bias. This is it's like open, okay, open circuit. If the current go this way, then it will go straight. No current flowing through this because this is reverse bias. But in negative half cycle, when the current flow this way, provides an alternate path for reverse bias leakage current that would normally flow through meter movement and T1. Okay, so if it flowed for the negative cycle to go this way, the current will the current will go this way. So through this and this. So for negative cycle, only leakage current going through this, no current flowing this. That is half wave. Okay, so it only provide alternate path for reverse bias leakage current. If there is no current cannot go in there, it will flow here, but it is not going through the meter movement for the negative cycle. Okay, so from that circuit, we know that VSH equal to VM equal to IMRM. Okay, you can see the circuit and then you can understand this. VSH is equal to VM IMRM. So VSH basically here is IMRM. Okay, so V here equal to V here, which is IMRM. Okay, second ISH is VSH over RSH. So this is normal. IT equal to ISH plus IM. So IT here, I total going here, go to IM plus ISH. So here IT go to IM plus ISH. Okay. So RT, R total, SDC multiplied by VDC or SEC multiplied by VRMS. And therefore, RS equal to R total minus RD plus RSH parallel of RM. Okay. So for this case, there is RD. Diode is given resistance value. Normal operation, we assume this RD equal to 0, but in some cases, there is a small value of RD which you need to include in your calculation. So how is this? This is RD. Sorry, in this case, if you see from here, R total is RS. R total equal to RS plus RS plus uh, what is that? RSH parallel RM, right? Okay. So RT RS plus this one. This one parallel first. RM parallel RSH. Okay, parallel plus RD plus RD. So, because there is no current here. So RS plus RD plus RM parallel RSH. Okay, you understand how to calculate the R total, how to simplify the resistance. You should learn this in circuit 1 subject. You parallel this first and then plus this one, and then if there is resistance here, you parallel with this one, then plus this one. Okay, example. Okay, straight away example. So using this circuit, the same circuit just now, in the half wave rectifier shown below, okay, half wave, they call it, this is, we can call this is commercial. In the commercial, red line, I like it red. For commercial, in the commercial half wave rectifier shown below here, D1 and D2 have an average forward resistance of 50 ohm. So this is where RD come in. This is RD. RD1 and RD2 go to 50. Right, 50 ohm. Assume to have an infinite resistance in reverse bias. So reverse bias, open circuit. Infinite resistance means open circuit, like it is not there. Okay. Calculate the following. Okay. RS value, SDC, SCC. Okay. So can solve this by using the question here. Okay. Given that E 10 volt, RSH 200, IFS 100, RM is 200. Okay. Solve this equation. You can try using this equation. Okay. Boleh. RS using this equation straight away. Boleh. Okay, let's see. RSH is equal to RT. RT ada. RT tak ada. So you need to calculate RT. RD. RD ada 50. RSH given. RM given. So what is RT? Okay. So RT basically V over I, right? So R total equal to EDC over I full square. So you have the E and you have I. Okay. So EDC basically for half wave is 0.45 VRMS. IFS is given 100 microamp. Okay, so you can, this one also can be written in terms of S AC multiplied by range. Okay. Okay. So just fill up this one. Okay, change to this one, and then minus this one. Okay. So you can solve this problem. Solve yourself. Please. So let's try. Solve first. One of these saja saya ingat. Okay. Okay, that's all. We will discuss about AC voltmeter full wave in the next slide, next topic. I hope you can understand a little bit about this topic, half wave rectifier. So we'll discuss in the next topic about full wave rectifier. Um, so that's all for now. Thank you very much for watching. Please comment if you have any question, then please let me know. Please let me know. That's all. Until then, Assalamualaikum warahmatullah. Bye bye.